In the present video, I'm going to talk about a plugin called Custom Glyph. This plugin provides two symbols that can be used to represent gradient and laplacian, a couple of concepts from vector analysis. So it's mostly to write those symbols, and so we're going to talk about those in the present video. And we're going to start with this SMath Studio file. I have loaded already my plugin that is called Custom Glyphs. And this one just provides 4 functions. You can check it out by clicking in here, selecting Custom Glyphs, and you have gradient with 1 element, gradient with 2 elements, Laplacian with 1 element, Laplacian with 2 elements. When you enter those, you get a Laplacian with an empty space. When we introduce this symbol, for example, all we could do is just add a letter here to represent a function, and we have the gradient of. Here we have the gradient of evaluated at a certain point, the Laplacian of, and the Laplacian of evaluated at a certain point. You can use it to type to type mathematical equation. For example, here I'm using the symbol and just an equal sign with text. And then I'm using the delta character control, the D control G, to represent the partial derivative symbol. And so the gradient of phi is the partial derivative of phi with respect to x in the direction of the unit vector I, the partial derivative of phi with respect to y in the vector direction j, unit direction j, partial derivative of phi with respect to c in the k direction. And another way to represent the gradient will be to use a column or a row vector, and the elements will be those partial derivatives as we indicated before. For the Laplacian, we could try to use delta squared, but that introduces a times point in there that doesn't really belong in there. So if you ignore that, then you get the definition of the Laplacian right here. Suppose that you want to apply it to a particular function. I have the function phi defined by this way. I decided, well, I'm going to build my vector and produce the derivatives using the actual derivative symbol from SMath Studio for with respect to x, with respect to y, with respect to z. But when I try to evaluate, I get 0. So that the building of this vector doesn't work to provide the right derivatives for this. One thing you can do is actually calculate those derivatives separately, utilizing the function diff in SMath Studio, and then copy those results as the components in x, y, and z. I also tried to use, for example, the definition for the Laplacian using the second derivatives, but again, I get the wrong result, 0. And again, what I could do is just take the second derivative separately and then build them into the definition of the Laplacian. And for this case, I get this value. If I let values of x, y, and z be -1, 2, 4, then those are automatically included in these definitions, and I can get my gradient to be this and my Laplacian equal to. The gradient with 2 elements and Laplacian with 2 elements can be used to define actual values. So you can use this as this complex expression as a variable. But remember, it's not really a function; it's just a variable. The same thing with this Laplacian. In the next example, I clear the values of x, y, z, and phi. And instead of just defining phi as a variable, I'm going to define it as a function phi of x, y, z. When I do that and actually include the derivatives of phi of the x, y, z, I do get the right result in defining the vector. And I do get the right result in defining the Laplacian. You cannot simply replace the values of x, y, and z. What I did here, I defined del phi and del square phi. Del is the name of that symbol right there, the little inverted triangle. And after I replace the values of x1, or I define the values of x, y, and z here, the values are included into the definitions and calculated like this. Would it be possible to define del z of x, y, z and del square? Well, I tried that. I cleared these, redefine the function. But when I do that, the definitions don't work. So that's because this x, y, and z only applies or only accompanies the phi, not the del phi. And so that's not possible. And however, the second derivative, it's allowed. It's allowed in terms of the components of, or the sum of these components. But when you try to replace values of x, y, and z, you get an error. So you just have to be careful. The Custom Glyphs plugin is mostly for utilizing the gradient and Laplacian symbols for writing mathematical equations, and you can actually calculate for some functions. You just have to be careful to follow the advice presented in this video to use those symbols, and in this way we conclude this presentation about the Custom Glyphs plugin.